So before we open it wide up to questions, just looking at this, and it really helps when people come in and ask questions, because then I can get a bigger picture on things. There's some stuff that's missing in this review, some types of questions, and some of the harder ones. I mean, one is determine what the rate law is. So you have to determine the exponents by comparing experiments 1 and 3, for example. That's not in here. Another one that's not in here that was kind of tough was the one where they give you this compound and they say that it's gold and its lattice, the side of its lattice length is so many nanometers, and then they give you the density and they say, what is it? What type of lattice? Face center cubic, body center cubic, right? That type of problem isn't in here either. The Sunday review, the Subway opportunity of success, or other way around. I've got a whole bunch of problems there, and all that stuff. We'll have a lot more time there. Here, we may not even have time to get through all these. But so let's start before we just start working the problems. Make sure here's what you're going to get on the exam, right? All these equations. I call them equations. They're really definitions, but we treated them as mathematical equations. Okay, and then our boiling point, elevation, freezing point, depression problems. And you had to recognize whether you had to use the equations with little I in it or not. And then we have these first order, second order, zeroth order equations, right? Just have to know what the variables represent and how to mathematically manipulate those expressions. So why don't we just go ahead and get started here. So number one, see if you remember how to draw the phase diagram of water, right? What were the axes, and sketch it in. You can pick on, I don't have any names here. Summer, what were the axes for a phase diagram? Any phase diagram. They were what and what? Now don't say potential energy, because that's a potential energy diagram, right? Potential energy and reaction coordinate. It's not that one. It's pressure. Very good. Pressure and temperature. Exactly. Okay. And remember you had to label 2 points. What were those points called? Critical point and triple point. Okay. So you remember how to draw this thing? You had to label solid, liquid, gas, the curvy thing, pretty much a Y, right? And then for water, did it go like this, or did it go like that? The first one. It goes back. It's the only compound that does that, right? So label your triple point, your critical point, then you have to put in the solid, liquid, and gas. Victoria, where does the liquid go? Oh, no. That was the gas. The gas is all that. The liquid is in the middle. That little section in the middle is our liquid. Right? So the solid and gas. It's only for water. And the trick to knowing that, the only way they're going to tell you that is, I would back up. Remember waters. And because you know that ice floats, or does ice sink? Ice floats. So the density of solid water is less than or bigger than? It's of the liquid. It's less than. So that's why it's going back. So when they have, if there's a phase diagram question, that's why they always tell you the density of the solid and the density of the liquid. If it's opposite that of water, the lines go in the opposite direction. Okay. See if you remember anything about intermolecular forces. Arrange the following in order of increasing boiling point. So lowest boiling point to highest boiling point. We had, what was the weakest intermolecular force? It was what? Dispersion or London, same thing. And there's more dispersion or London forces for molecules that were bigger. Yeah, that's how you went. And then the next step up, a little bit stronger, were dipole-dipole. And how you know if you have a dipole, you pretty much just have to have something really electronegative, right? And that group 7 essentially, with something that's not electronegative so much, like H or something. Like HCl would be a really polar compound. Dipole-dipole. And then the strongest one out of all of them, hydrogen bonding. H with O or F, even N sometimes. It depends on the book, but pretty much O, N, or F. Okay. So, which compound here, A, B, C, or D, is going to have the lowest boiling point? It would be, everybody agrees, D? Yeah. That's all it has is London. And then you'd have C. All it has is London, but it's a little bit bigger. Then A. Now both A and B have hydrogen bonding, but why is B last? Yeah, it has oxygen, which is more electronegative, and it's also more freely available, right? It's more easily accessible for this OH kind of stuff. Okay, let's see if we can remember some of these types of questions. Okay, now there is a general way to attack these that's the same no matter what the type of question is. And my suggestion on attacking these is you treat all of this stuff like an algebraic equation. Just know what all the variables represent. So then when you read a question, you just go look for the right equation. So you don't have to memorize this stuff like, oh, temperature needs to be in what units, or this I need the moles. No. You just look at the question, see what they want, and then find the right equation, and then work with it. So here's our question. What mass of solution? Okay. So they want to know mass of solution, right? So you go up here. Here's all of our equations. You don't have much choice. It would be which one? Yeah, mass of solution. Right? You're going to solve for this. Okay. So mass percent. I already forgot what the heck I wrote here. Mass of solute over total mass. Of solution times 100. Okay. We're going to solve for the mass of solution. That's what it wants. You should be able to pick out everything else, substitute it in, and your answer should come out to be 23.1 grams. See if you can get it to work. The question had to tell us everything else. Mm-hmm. Calculator? Remember on the exam, Jasmine, you have to use one of these. Make sure you know how to use it. Right? Remember your cross multiplication or your diagonal story to solve for things, and just see if you can get used to that. All right. Question marks on the bottom, so you got to bring it to the other side. Move the 6.5 down where the question mark was. You should have your answer. Did it work? All right. Yeah. And you end up with question mark equals 23.1 grams. Did it work? Brandy, you got it? Okay. Let's try the next one then here. Caffeine found in tea and coffee. Sample dissolved in 45 grams of chloroform, which is CHCl3, to give a 0.0946 little m. I'm not supposed to say little m. I'm supposed to say molality solution. How many grams of caffeine were in the sample? Okay. There's your answer. But how are you going to get it? Monica, what equation are you going to use for this one? The molality equation. And that was defined as what over what? There you go. All right. Now, they want to know how many grams of caffeine were in the sample. Right? Get comfortable with this. Converting what to what is what I'm driving at, AJ. Get comfortable with converting what and what. Well, yeah, that's important. Kilograms to grams, that's right. Moles and grams of something, right? When you see moles of solute in an equation, realize, hey, if I know what the identity of the solute is, I can convert grams to moles or moles to grams. It's no big deal. So that equation has grams in it, right? You can easily convert. So the answer is right there. It's right here. You just got to convert. It's going to be a two-part question. That's the answer. You just have to convert. And AJ's right. You're going to have to be comfortable with going from grams to kilograms for sure to use this. See if you can get it to work out. Lauren, did you get this many moles for the stuff? Did you get that far? Mari, did you get that for the moles? 4.527 times 10 to the negative 3. Zero got it. Right? Remember the diagonal story. All right? The mole's already up on top, so leave it alone. Don't mess with it. Just get rid of that 0.045. So you have to multiply to get that. You have to multiply 0.0946 times 0.045. Hoping somebody got this far, because I don't really feel like adding up 8 carbons, 10 hydrogens, 4 nitrogens, 2. What'd you get?
I got 4.257.
No, I mean for the molar mass. 194. Oh, what were you saying, Summer? You didn't get this one?
I got 257 instead of 5.
0.0946 times 0.045. And then folks are getting 194 here. Oh, is it 4.257? Yeah. What is that called when you switch around numbers? No, I'm not dyslexic. Jeez. Talk about the glass being empty. My gosh. All right. 4.257. Sorry. But someone added up the molar mass. Anybody else get 194? All right, that's got to be right. Add up 8 carbons, 10 hydrogens, 4 nitrogens, 2 oxygens, they get 194. Okay. Now I'll take it times 194. Finally around 0.83 or so. Somewhere around there. And that's what the answer is. If you're just struggling with it, ask. Otherwise, try the next one. So take a look at the question. See what they're asking for. That's how you identify the equation that you're going to be plugging stuff into. If they give you extra stuff, who cares? You don't need it. Just go for what they're asking. Mm-hmm. Okay, that came from the 0.0946 times the 0.045. You have to take that. That's 0.0946. 0.0946. Because you're solving for. Where's your equation? Here. Right? You know that. You know this. You're solving for him. But he's already up on top, so leave him alone. Just bring the kilograms up on the top on the other side. Then you got to convert it to grams using molar mass. You already got it right there. Anybody have a shot at number 100 here? Okay. Let me get on to something here. It's either this one or it's this one, right? Because if you remember that osmotic pressure is pi, you're set. Which one is it? The first one. How do you know it's the first one? There's no metal. That's a perfect way to see it. You look at this compound. If there's no metal in there, it's got to be a molecule. It's not going to break up and form little ions. So no metal. So this guy is not it. Okay. Now what in here pretty much tells you what units to use for everything. that R does. And I give you the R, right? So there's no memorizing what unit's got to be. You just plug stuff in. Look what R is. R is in what? Liters and atmospheres all over moles Kelvin. So atmospheres is good. Don't mess with it. Our temperature's messed up though, but you can get it. On your way out, make sure you grab what's in your folder there. So hopefully you got 0.225. Alrighty then, let's check out the next one here. Which aqueous solution has a lower freezing point? Which aqueous solution has a lower freezing point? They're aqueous, so that means the solvent must be liquid, but water, right? Solvent must be water. Water usually freezes at 0, right? But if you dissolve something in it, the freezing point's going to go down, right? Freezing point depression. So in which solution does the freezing point go down even further? Is it the KCl or is it the calcium chloride? Why? Well, an equation might help. What equation would help us? What is it? Delta TF equals okay. Do we want the one with the I in it? Yes. Where is the metal in KCl? K. Where is the metal in the CaCl2? The Ca. Okay. So if you're going to apply this equation to each one of these solutions, what doesn't change? The Kf definitely doesn't change. All right. This guy doesn't change. He's the same. What else doesn't change? What's that? Yeah, that concentration. Right, he's the molality. He's not changing either. They're both 1. The only thing that could change is the little I. Does it? Yeah, it does. Ramiro, how does it change? For which one? Yeah, there's 3 ions here. Everybody KCl has 2 ions. Did you notice there's a quick and dirty way to get the number of ions? If there's a metal, there has to be a metal. That's rule number 1. If you see a metal, there's a quick and dirty way to get the number of ions. Just add the subscripts. But then, like all quick and dirty ways, there's something that's going to screw you over. If there's a polyatomic ion, you're screwed. So it's not safe to be adding these subscripts up all the time. Because take a look. If I do like potassium carbonate or something, right? You add up all the subscripts, 3 and 1 is 4 and 2 is 6. No, there's how many here? There's 3. Carbonate is 1, and then 2 Ks. So there's only 3. So there never is. It's always the solution. They tell you what the compound is. So the answer is calcium chloride. That has a bigger I. I is 3. The other one, the I is only 2. So they get a bigger delta T. Okay. This is a tough question. They give us a reaction. And they say it's first order. Right. And they tell us some stuff. What was the concentration of cyclobutane after 750 seconds? So where should we start on something like this? Get the equation. So Alyssa, what equation would we be looking at? Yeah, she's reading out this one, right? Because they said first order, and what symbol in here is our answer? What variable? Go back so you can see what the question was. What variable is our answer? A with a little t, right? What was the concentration after 750 seconds? So what would, right? There it is right here. That means AT equals what? Okay. We'll be right there. I just want to write this down so make sure everyone sees what we're headed here. Natural log of A at time t, A over 0. I'm just copying down the equation that Alyssa was reading. So that means we should be able to plug everything in there and solve for A at time t. So let's try it. All right. This is the guy we're going to find. The initial 0.0015. Okay. How about the other side? T is 750. Do you see a K? Yeah. Some couple folks are seeing what to do here. Look at all this extra information they gave you. Right? We don't know what the K is. So let's find it first. Right? Once we figure out what K is, then we'll plug it back into here with all these other numbers and we'll solve for a concentration of A at time t. So how do you get K? Monica, what were you saying? The other numbers, which are what? Here's a time. Yep. Yeah, what number? The AT is going to be... There it is. Here's another AT and its corresponding time. Right? We need to know an initial. Same initial. So we know everything but K. So solve for K. All right? Then plug it back in over here, and you should get it. Okay. So find K first. If you get it to work out, here's what K will come out to be. Okay. Find K first. Substitute that stuff in there that Monica was telling us. Find K. See what to do, Mari? Okay. So you see the equation makes sense though, right? What equation to use? Yeah, the ln one. Except we're missing a k, so we can't solve for a at time t. So let's use the one in green first. So write down that equation and substitute everything in there. The a at time t is going to be this. The t would be that guy, right? Our initial would be him. So that means we know what all those are to solve for k. Did you get k to be 5 times 10 to the negative 4? If you're not getting k to be 5 to 10 to the negative 4, let me help you out. So to do 0.001, do 0.00119 divided by 0.00115, or sorry, it's 15, equals. Now you do natural log. It's just the ln. That one right there. No, because it's just one number over the other. We have to take the natural logs. You have to push natural log. It's that one. Yeah. So that number, negative 0.2315, is equal to negative k times 455. Now don't raise everything to the e because you have to take the natural log of this. So 0.00119 divide by 0.0015, hit equals, then natural log, the ln button. Then you get this. Notice how the negative signs are going to cancel on you. Divide both sides by a negative 455. And yeah, you get the 5.08 times 10 to the negative 4. Which is what it's supposed to be. And now you plug it in. All right? We'll have ln at a at time t times 750. So you got to solve for that a at time t. Now you have to raise both sides to the e power, right, to get rid of that natural log. Because our answer's inside the natural log. That's why we have to raise it to the e power now. So once you raise this whole side to the e power, notice that you have to multiply them by 0.0015 to get your final answer. Natural log disappears. Oh, I screwed up. Yeah, about 1.02 times 10 to the negative 3. Just don't forget to multiply by the 0.0015 after you raise it to the e power. So if you got it, try the next one. Okay. Now you have to take this times that. That's what you raise to the e power. And once you raise it to the e power, whatever you get, this is just a number. Whatever you get, that number equals this divided by that. So you have to multiply this both sides, all right? So whatever e to that power, take it times 0.0015. And that's your final answer. Did you get it to work? Yeah. Okay. Yeah, so now if you find initial, this has to go up on top, that has to go on the bottom. Yeah, so you're going to divide this by that and you'd have it. Try to knock out the other ones if you got it. Anyone not get this one? 62. What should the rate law be? Yeah. Right. So Vanessa, how did you get this one? Did you get 118? Did you get this question? All right. Anybody have a suggestion for 118? Rate equals K times, yeah, in brackets, exactly, that big thing. Yeah, that first one. Because it's the slowest, and it's an elementary step. That's the only reason why you can do this. Just copy it down exactly as it's written there. All right, you can raise it to the 1 if you want. What's that?
Because I saw it has two different, like, I thought it was the CH was one and the.
Oh, it's. I just copied verbatim as to how they wrote it. Then I don't worry about it. Well, we don't need to turn any. We're not turning anything in today. Yeah, I'll just hang on to it. Otherwise, there's no way I'm going to get it back. There's no way I'll get it back. For you to use to study for the exam. I already apologized. Remember that I couldn't give out a quiz? Okay, how about this number, last one here? Do you remember what I suggested to be the starting point for this kind of thing? Writing molecular weight equation. Yes, remember? All right. What's that? Oh, close enough to 123. All right. So you're after molar mass, so that's where we started out. And we already know the grams. You just have to figure out the moles. So we have to get, what, little freezing point depression. Well, they already told us the molality. Some of these questions, they have us calculate molality first. Here they just told it to us, right? You just go ahead and use the molality equation. Just set it up. And here's our moles. Plug it in. And you'll get it. Okay. Yeah, but essentially done. Right. Just our definition. So the Sunday Subway opportunity for success, I've got a bunch of questions we can go over, right? Especially some of the ones that were pretty tough, and because we didn't get to, like I said in here, the questions with lattices, right? Face centered cubic, body centered cubic, right? And questions with writing a rate law, giving a whole bunch of experiments. Okay. So if you don't make it to the SOS, make sure you study those types of questions. So have a good day. Well, typically like 10 questions, 10 problems. Unless there's some easy ones, then there could be like 12 questions. There's some short answer ones.